Hello, Maurieos slopes and grades quiz. Hello. In this video, I'm going to take a look at my slopes and grades quiz. One of my students has emailed me and said that they're having a wee bit of a problem with some of the questions. So I'm going to take an in-depth look at the questions in the hope that we can solve this problem. So let's get on with it and go to the large screen where we're going to use Smooth Draw. And here's the quiz all set up and ready to go. So let's have a look at the first one. I might just take a little bit of time here just to find my calculator that I use. This is a calculator that I downloaded at some point from the internet, and it's a Casio FX82 calculator, and I'm hoping calculators, here it is here, just a little executable file, and there's my calculator has popped up there on my second screen, and I'm bringing it across here. And now back to Smooth Draw, click on my calculator, and there it is, just ready in case we need it. So, using a level, RJ determines that his driveway rises 2 meters over a length of 50 meters. Write the gradient as a representative fraction or ratio in the form 1 to x. So the first thing we do is draw a diagram. We're using blue. Okay, so here's our diagram here, usually in the form of a right angle triangle. And he says that his driveway rises 2 meters, so that'll be 2 there, and it's 50 meters long. Now when we talk about lengths or distances, unless we see something to the contrary, we're talking about horizontal distances. So that's the situation there, and the gradient, oops, just running out of room there, gradient equals rise over run. Okay, which is, I'll put that in here, rise over run. And that equals rise 2 meters, run 50 meters. Okay. Now, we've been asked to put that as a representative fraction. It's just a matter of writing it there. It's just would be like this, 2 to 50. So it's like the little dots. It's a represent the bar, and it's a way of writing it there. Now, 2 to 50, we usually like to have it in 1. So let's divide through both sides by 2. It's sort of like an equal sign, the ratio sign, and that gives us, so it's still the gradient, equals 1 to 25. And that's the answer. Okay. Enid's driveway falls 3 meters over 48 meters. So this driveway here is falling 3 meters over a length of 48 meters. Okay. Express the gradient as a percentage to 2 decimal places. So the gradient to 2 equals rise, which is 3, This one here would be plus because it's going uphill. This one here would be minus because it's going downhill. -3/48. And then to make it a percentage, we just multiply it by 100 times 100 equals, and then I just grab my little calculator, move it into a convenient spot, and then we just go 3 divided by 48 times 100 equals 25/4, and we just push that button there, 6.25, and that'll be percent. 6.25%. Okay, Sid's driveway rises, so, and that's going to be negative 6.25% because it's falling down. Sid's driveway rises, draw a diagram, 8.82. 8.82 over 50 meters. I'll just draw that in there like that. Calculate the slope of Sid's driveway in degrees to the nearest degree. Okay, now Sid's driveway, so the grade equals rise over run, which is 8.82. 8.82 over 50. And it's in fact the angle that we want, or let's have a different colour. The angle what we want is this angle in here. That's the angle. And, you know, if you want to write down Sokotoa, so you can do it using trigonometry, Sokotoa. That's the opposite of the red angle, that's the adjacent, that's the hypotenuse. You know that, you want to find an angle. So it's tan. So we know that tan of the angle, let's call it theta. Okay, so we know now that tan theta, the angle we want, equals 8.82. Whoa! Slipsies over 50. Okay, so therefore we know that theta equals tan to the -1. (8.82) over 50. Okay, and theta equals, so let's get our little calculator out here. Alright, so we go shift, let's just clear here, shift tan, no that's not, that doesn't look right, all clear. I might go with the mouse rather than the pen, so let's go shift tan to the -1, that's better, 8.82 divided by 50, close the brackets, equals, and that gives us 10.004 10.004 05749. So that's degrees. That's degrees and decimals, and just 10.004 05749. That's degrees. Now, if we want to make that into degrees and decimals, we've just got to hit this little button here, this little degrees, minutes, and seconds button, and that tells us that that's 10 degrees, 0 minutes, and 15 seconds. And 10 degrees to the nearest degree, which is what the answer wanted. 10 degrees to the nearest degree. Well, good. Okay, so that's Sid's driveway sorted. All right. So Sandy measures the invert level of a 150mm PVC pipe at manhole A as 15.63 meters, and at manhole B 63.47 meters away as 14.89. Calculate the gradient of the pipe as a representative fraction or ratio in a 1 to x format to 2 decimal places. So, let's have a diagram here. So what we've got is we've got these two yellow's not a good color to use. Let's undo yellow. And for some reason the brush size has got all haywire as well. Don't know how that all happened. Okay, so let's go with red perhaps. Okay, so let's draw. We've got a little manhole here. Here's a manhole. Okay, and invert level 15.63, and so it's rising up. So we've got another manhole here. Put that there like that, and then I'll put the ground in here like that, and then we've got a pipe running between these manholes. Now the oh no, that's not right. I've got it around the wrong way. I've got things running downhill. Okay, so this manhole here needs to be lower. So this is why we draw diagrams, so that we can just get a good idea. Like that there, and then this is the ground, and then we've got a pipe that runs from here, hopefully not like that, in a straight line. Now the invert level, that's the bottom of the pipe. The bottom of the pipe is called the invert level, and we would write there IL for invert level, and the invert level, this is A, and this is B. Okay, and the invert level at A is 15.63. Okay, and the invert level at B is 14.89, so it's lower. The invert levels are levels above sea level, so obviously This one is more above sea level, this is less above sea level, so the water's going to flow in that direction. And then the distance A to B, which I'll indicate here, the distance A to B is going to be, it says there 63.47. Okay, now what we need to do now is, right, 63.47. Okay, so rise over run gradient or grade. Now the rise or the fall, the rise in this case is falling, is negative .63 over 63.47. Now what we do here is we divide, I'll just put that in blue maybe. We divide, what we do is we want it as, it's as a fraction, but we can put it as a ratio just by getting it, we want it to be 1 on the top. So we equal 15.63 divided by 15.63 to make that 1. And we do the same on the bottom. Oh, sorry. Should have put the 63.47. So it's going to be something 1 to 4, something like that, I'd say, divided by 15.63. And that equals, okay, let's get the calculator out. So here's our calculator here. So let's go, my error, my total, I've stuffed that up. I'll just go back and fix that up. So I'm just going to undo that. What I forgot to do is take off the little bit. Forgot to, it's not 15.63, my mistake. What I've done there, keep going back. It should be 15.63 minus 14.89. So to all of those people that are thinking, what is he doing? And that should be in a bracket actually, because yeah, the negative just indicates that it's going downhill. So I'll just check that that is 14.89. Yes, now get my calculator out, which has conveniently disappeared. So I'll just have to make it appear again. Poor little calculator got frightened out of the picture altogether. And back to smooth draw and get our calculator back up. All right, so this time, so now it's 15.63 minus, and that's the 14.89. So that's the rise, or in this case, a fall. And that's equal to 0.74. and then we divide that by 63.47, divided by 63. No, I'll just stop there. I'll just write that in there. Okay, so that equals 63. Equals 0.74 divided by 63.47. Now that that'll equal 0.74 as a ratio to 63.47. And then if we divide both sides by 0.74, that equals 1, 2. Get my calculator out, and let's just go here, clear. So that's 63.47 divided by 0.74 equals 1 to 85.77. .77 2dp. Okay, 85.77 2dp. Okay, so that's that one done. Yeah, it was a little bit, took a while, but yeah, we don't always get it right the first time. Sometimes a little bit of trial and error is required. Okay, so now looking at this one here, typically the crossfall from the center of a road to the lip of the channel is minus 3%. If the carriageway of a road is 8.4 meters wide from lip of channel left hand side to lip of channel right hand side, how much higher would the center of the road be above the lip of channel? Answer in meters, 3dp. So let's draw that up, shall we? What's that color? Oh, red. Draw it in red. Okay, so here's might just start a bit lower down than that. So here's typically our curb and channel looks like that, and we have one on each side of the road. Looks something like that, and then the road generally goes up like that. In that case it's minus 3%. Well, that's from the center of the road down, it'll be that way. That'll be a negative, by the way, that'll be a negative gradient there because it's going downhill, so we could put that in minus, it's going downhill. So yeah, negative. So perhaps we should take the lower from the higher. Okay, that's negative 3%, and then we got a total chainage or distance 8.4 lip of channel to lip of channel. So across there's 8.4. So these little distances here to the center line, 4.2. Now, okay, how much higher would the center of the road be above the lip of the channel? So let's just get a little blue in here. So what we've got here is this in here. So we know that this is 3%. We know the distance is 4.2. Okay, so, and we know that 3%, okay, 3%, okay, that means 3 per 100. So it's a 3 per 100, which if we divide both sides by 3 is 1 to 33 1/3. That's a 3% grade up there, and that's 4.2. Okay, all we need to do there is we want to find what x is. X over 4.2 equals 3%. Okay, which is equals 3 over 100. 3%. Okay, so 100x equals 3 times 4.2. Okay, and x equals 3 times 4.2 divided by 100, which equals 12.6. Okay, equals 0.126 meters, because our units of 4.2 was in meters. Okay, so it would rise up 0.126 meters. Okay, and that's 3 decimal places, which it should be 3 dp, nearest millimeter. Okay, so yeah, 3%. It's the easiest way to do it is just to write it as 3 over 100, but normally all you do is multiply. It's also, I mean, very quickly, if I was doing that on a job, I would just be going 0.03, which I know to be 3%, times 4.2 would give me the answer straight away, like on the just in my calculator, or I might even do it in my head. So all clear, 0.03 times 4.2 equals 0.126. All done and dusted. Okay. Typical cross. Oh, well, they've done that one. That one's done. All good. The design carriageway for a rural road is 9.6 meters wide, lip of curb, and the design crossfall is -4%. If the design level, so this is the same diagram, just to save a bit of room, I might just draw this in here, I think. Oops, that didn't go so well. So then we've got this one here like this. Okay, and then we've got our road typically like this to there, and this here is 4%, -4. -4% there, and we've got the center of the road is 182.43, so that's just a level like so, 182.43 -4%, and 9.6 from there to there, 9.6. Half of it is 4.8. Okay. If the design level, what would be the design level lip of curb? Okay, so we're going to go across at 3% of -4% for 4.8 meters. So very quickly, I would just go 4.8 times 0.04. That will give us a crossfall, which is that's going to be equal to, on my little calculator, twice 9, 4.8 times 0.04 equals 0.192. And so the level is going to be, of the lip of the curb, is going to be, I'll just put left hand side lip will equal 182.43 minus 0.192, and that will equal 182.238. meters. So it's just this little distance in here. (0.192). Okay, now what have we got now? Oh, sort of running out of room. A roof truss. Okay, a roof truss spans a distance of 8 meters. So typically a roof truss looks like this, and the span is 8 meters, which is there. 8.00, and the pitch is 30 degrees, which is this angle in here. Okay, what is the minimum length of long run roofing iron that would be needed? Okay, so we get a right angle triangle here. That's 30 degrees. This is the roofing iron. This is X in here. This is what we need. The length of the roofing iron there, X, and X, okay, so that's X there. So what we need is, we know is that that's a right angle triangle there. That there's H. This here is the adjacent, and we need to find that. So let's just go Sokotoa. So we know we want to find the hypotenuse. That's what we want to find. We know the adjacent is 4, and we know that it's 30 degrees. So it looks like we're going to be using cosine. So it's cosine 30 degrees equals 4 adjacent over X. So going up here we get X cos 30 equals 4, dividing both sides by cos 30, X equals 4 over cos 30, which equals 4 divided by cosine 30 equals 4.619 meters 3dp. .619 meters 3dp. Okay, now got one more here to go. One more here to go. We're getting on. It's taking a little while. Let's get through this sheet. Around about 40 meters so far. Okay, you are laying a 600 reinforced concrete rubber ring jointed pipe at a 1 to 20 grade away from a manhole for some 85.27 meters. So here's our manhole here. Okay, put that there. Okay, and we're laying away, and it's going at a plus gradient, so it's going uphill, and the distance is going to be 85.27. and the gradient is 1 to 120. Okay, to manhole B. So this is A here. So draw a diagram first, always good idea. Manhole B. Here's our pipe. If the invert level of the pipe is 85.635, what will be the input pipe at B, meters 3 dp? So what's happening there is we're going 85.27 meters. So if it's going to go 1 meter in 120, 1 to 120, it's going to go 85.27 divided by 120. It's going to go that many meters in 85.27, and then we add, so that's going to be like our rise. Oops, that's not what I wanted. So we're just going to go here. So that's 85.27, that's the rise there. Okay, so we just need to calculate that. It goes 1 in 120, it's going to go that much in 85.27, plus, I'm going to go back to the magenta, I guess, plus 85.635. So the key to these questions is to draw the diagram. So so this will be ILB. So it's going to be equal to, and get the little calculator out, 85.27 divided by 120 equals, so that'll be a fraction of a 0.710. That makes sense because it won't be as much as a meter. Okay, and then we go plus 85. 0.635 equals 86.346 to 3 decimal places. So that's 86.346 3 dp. Okay, so that will be the invert level of B. Alright, so if it's goes up a meter every 120, so it's only going to go up 85.27 over 120 meters in 85.27 meters. So that gives us a little bit there, which is we can work out. Well, we did work it out, and yeah, and then we just add that to 85.635, and there it is there. Let's just check that with our calculator. Here it is there. Yep. Let's just see what answer equals. Oh no, I thought we might have that there. 80. I'll just check that. 85. All clear. 85.27 divided by 120 equals 0.711. So there's, I'll just put that in there in blue. 0.711. Okay, so that's the answer to that one. I have produced a set of answers which also appear on the Moodle site. Now let's have a look. A batter slope often encountered in the field is 1-to-1. This is called a 45-degree slope. 1-to-1, 45-degree, or 100%, which you can get from my previous video, slopes and grades. Gradients or slopes are dimensionless, as they are not dependent on any particular unit of measurement. And again, that's from my previous video. So I'm hopeful that with this video here, long as it is, you may be able to help find some help with some of these questions. But the key to all of these questions is, to draw a diagram. Draw a diagram. Draw a diagram, draw a diagram. So let's draw a diagram. Draw a diagram, that is the key. Get the diagram going so that you understand the question, and then the maths, D-I-R-A-M. Hopefully you can decipher that to mean draw a diagram. That is the key. Draw a diagram, and then you're all away. So let's just head back here, and yes, there you go. I know this is a particularly long video, 47 minutes, coming up to 50. As I've said, the key is to draw a diagram. Understand the actual ideas of the gradient are all based around the right angle triangle. So the right angle triangle gives us Pythagoras, it gives us the trig ratios, sine, cos and tan, and also a number of quite simple relationships that I've depicted here for gradient. So hopefully this will help you see your way through this. Most important that you understand gradients, as they are an integral part of civil engineering, and need to be understood very clearly, that they can be both positive and negative, and also you need to be able to quite often work these out in your head, or with the aid of a diagram. Usually you have a calculator available on your cell phone or a calculator, but yeah, it's quite often these sort of calculations are done down in the dust and dirt, so you need to be able to do them competently and relatively quickly. But the key is draw a diagram. Cheers! See you!